All right, what can I do for you?
Under review questions that you posted, can you do the question number 6?
Sure, let's do it together.
Mhm.
All right, calm down. Some, sometimes my dog, Rocky, I think he's trying to get me to give him something to eat. He's protecting me. All right, let me pin this. All right, lie down, lie down. The review questions for test two. Number 6. So it's, oh yeah, so we're going to prove this. For all integers A, B, C, and D, if AC does not divide 3BD, then A does not divide B, or A, no, C does not divide D. Yeah, I gotta get that right, don't we? So can you help me write the contrapositive? Because we're going to prove this by
Oh,
contrapositive.
okay. So it's gonna be for all A, B, C, D, or Z.
Good.
It's gonna be um, if A, then B,
Divides.
B, or C divides D,
Well, what does De Morgan's law say when we're going to negate an or statement, though?
and
Yeah, we got to switch it to an and, because we'll need both of those. And C divides D.
divides D. Then
Good.
it's gonna be for our it's gonna be AC divides 3 by BD.
Divides 3BD. Yep,
BD.
yep, that's exactly right. Nice. And so we're going to be able to prove this, like, we're proving this by contrapositive, which is a direct proof of the contrapositive. You with me?
Mhm. Yes.
Great. So let's write our proof by contrapositive. So what should we assume? We need a hypothesis.
So isn't that the hypothesis gonna be AC divides 3 BD?
No, our hypothesis is this.
Okay, so the one we wrote but for contrapositive. Okay.
Exactly, because we're writing a direct proof of the contrapositive, where we assume the hypothesis of the contrapositive, and we wish to show the conclusion of the contrapositive.
Okay.
So this will be our hypothesis, and this will be our wish. Does that make sense?
Mm-hmm.
All right, so what shall we assume or suppose?
So we assume that A divides B
Yep,
and C divides D.
great. Hey, Anticott, we're working problem number 6 from the review sheet. Good to see you. So what do we wish to show?
We wish to show AC divides 3BD.
Exactly. Great. So now what do we do?
So now we use the definition of divide.
Yeah, by the definition of divides, what do we know? So A divides B, right?
Mm-hmm.
So what kind of equation do we get from A divides B?
I don't know.
Hey, tell you what, let's do.
So
Do you know what? Because I was going to say we could write down the definition of divides if you need it to look at.
like I know we have to introduce like a K, so but I don't know how to do it.
All right, that's good. It's really good to identify that you need to learn the definition of divides, okay?
Mm-hmm.
All right, so let's just review the definition of divides. Hey, Eli.
Hey, Professor, how you doing?
Good. We are working problem number 6 from the review sheet.
Awesome. I had a quick question before you moved on.
All right.
I noticed that in class today that for the hypothesis, you put for this one for the hypothesis, you just said assume A divides B and C divides D. But I also saw in class that you also included the then statement as well. So is there like a criteria for when you would use um the if and the then statement in your hypothesis?
Yeah, if it's proof by contrapositive, when we write the contrapositive so we can see what we're proving, we write it as an if then. If we are disproving a false statement, like if we have an if, oh, where'd he go? All right, well, he'll come back.
I'm right here.
Oh, I
Yeah.
thought you disappeared. If it's an if then statement that's false that we're disproving, then we assume the negation. And the negation of an if then statement is not an if then statement. The negation of an if then statement is an and statement. Okay. Maybe that's what you're talking about.
It's part of it. I'm trying to find a word to describe like
Well, I'll tell you what,
yeah.
Eli,
Yeah.
Kadja was here first,
Okay, no
and
problem.
we're going to work this problem and then we'll sort you out. How does that
Yeah.
sound?
Yeah, no, that's fine. That's perfectly fine.
So X divides Y means, all right, so the way that you can help yourself here, Kadja, is when you read this to yourself, you can say X divides into Y. X divides into Y. It's not X being divided by Y. X is dividing into Y. So Y cannot be smaller than X. X can be smaller than Y, right? Y could be the bigger one. They could be equal, but a lot of times Y is bigger. So Y is a multiple of X. So Y equals XK, where K is an integer. That's the right equation for divides. Rocky,
Okay.
Rocky, what do you hear? My dog hears something. He never growls. He really never barks. So it's warm outside, and sometimes people poke around in the backyards when it's warm. So I live in the hood. So maybe he hears something. I'm glad to have him.
Mhm.
All right. So now, so when we've got A divides B, right? A is playing the role of X and it's dividing into B. B is playing the role of Y. Does that make
Yeah.
sense? So what is
Yes.
the great? So what is our equation?
B equals to AK.
B is equal to AK. Good. Where K is an integer. Good. And because we have more hypothesis, we have C divides into D
Mhm.
would be a nice
B D,
equation.
D equals to CK.
Oh, we got to use a different variable.
Oh, okay. So maybe J.
Sure. J, where J is in Z. Good boy, Rock. Fantastic. I tell you what, let's do the same game so we can figure out what kind of equation we're going to need right before we can say that it means that AC divides 3BD. So let's unpack this wish a little bit. So our wish is that AC divides 3BD. So what kind of equation do we need to show that AC divides into 3BD?
So is it like the same thing that we did before?
Yeah, the X
Oh,
is the AC and the 3BD
okay.
is the Y. Uh-huh.
So 3BD is equal to AC and
Where N is in Z. Nice. Did you say N or M?
N. I said
And
N.
that's fine. Good. So, and the other thing about doing this and looking real closely at this wish is that it helps us see that we need to look at 3BD.
Mhm.
And we're going to try to find an A and a C factor that will pull out front, and then N will be whatever's the other factor. So it's really helpful to know, hey, I'm going to be looking at 3BD. And so are you. See what I mean?
Yeah.
Great. All right, let's do this. Let's look at 3BD. So let's observe 3BD. What is it equal to? Well, the 3, we'll just write the 3 down because there's no equation for the 3.
Mhm.
But what do we have?
So B is gonna be AK
Yep, we'll put in the AK for
and
the B
CJ.
and CJ for the D's. You see how we're so close now?
Mm-hmm.
We just need to pull the A and the C out front. And now what does the other factor look like?
JK
And don't forget about the,
3
so 3,
3JK.
JK or KJ doesn't matter, right? Multiplication
Okay.
doesn't care.
Mm-hmm.
All right, great.
Mm-hmm.
So now that's part one of the definition of divides, but the definition of divides has two parts. What do we have to talk about?
So we consider that as a M
Or N, doesn't
and
matter. I
say,
mean, you called it N, but we can call it M, it doesn't matter.
okay, okay.
So now,
So,
see, because we haven't used this yet, and we
mm-hmm.
haven't used this yet. We're getting ready to use those. See, that's part two of the definition of divides. We use part two to get part two. We used the part one of the definition of divides to get the part one. It's always like that.
Okay.
All right. So since K is in Z and J is in Z, and if you want, you can say also that 3 is in Z. It doesn't matter. You don't have to say that, but you could if you want.
Okay.
And what operation is being used to build this factor?
Multiplication.
Okay, so how do you want to word this?
Uh, Z is closed under multiplication.
Perfect. So since K is in Z and J is in Z and Z is closed under multiplication, now what? You can just say we see
Okay.
N equals 3KJ is in Z. That's what we needed to say. We need to say that it's in Z, right?
Okay.
So 3BD equals AC times N, where N is an integer. which means, okay, what was our wish?
AC divides 3BD is desired.
By definition of divides. Exactly. You did it.
Okay.
So really the key is to carefully look at what the given statement is, and attend these variables, and then write the contrapositive carefully, assume the hypothesis of the contrapositive, and we wish to show the conclusion of the contrapositive. So this is a proof by contrapositive of the original statement. We wouldn't be able to
Thank
get
you so
very,
much.
you're so welcome. We wouldn't be able to get very far if we tried to prove that original statement directly, because we can't do much with does not divide. Anticott, you have a question? You were in next. See who else here?
We can't hear you, Antica.
Hi,
Carver.
Rick. Okay, good.
So I want to work on the special homework of like number 7 and number 8. The number 7.
Okay, and I'll tell you, number 8, we worked after class tonight, so it's going to be in the class recording tonight, I think, from tonight's lecture.
Oh, the night
Yeah, the
the
night
night
lecture.
one.
Yep, day 16 lecture. It's because we stuck around after lecture was over, and we did work number 8. I'll send around an announcement. So there's a recording of number 8, and I will post the notes, okay?
Okay.
All right.
So can we work on
Number 7?
question 4?
Sure. So let's see, what does number 7 say? You want to read it to me?
Oh. So the product of 3.
It's another divides problem, isn't it?
Yeah.
All right.
So we have to negate it first. If I
Well,
need
let's just write the statement down.
the negative one.
The original statement. It says proof. What does it say to prove? What is it? For
The
all
3 products of
A, B, and C, and Z, right?
no.
Number 7 from the review problems.
Oh, you talking about review? I'm talking about special homework.
Oh,
Sorry.
no problem.
So
Number 7, the one you just turned in.
the one is 8. Homework 8, special homework 8 too. So
Problem number 2.
no, number 4.
There aren't 4 problems in special homework 8.
No, I'm talking about 7. Okay, can.
Have you turned this in?
Yeah. I'm sharing my screen for
Oh,
now.
that's great. Oh, that's awesome. Thank you so much.
Mhm.
You're a pal.
So this
Okay.
one, number 4 here.
Can you make it a little bigger? And
Are you seeing?
plus. There's a plus up right next to that thing that expanded it. Yeah, yeah. In the middle. In the middle. See the plus and the minus?
It doesn't give me a
No,
finger.
it's in the middle.
Here?
Right above the word homework. There's a
Oh,
plus. See the plus? There's a above that in the black bar. Above it.
here.
Yeah, a little to the left, a little bit left,
Here.
left, just go left. No, that's other way. Keep going.
Okay.
Do you see the plus? You don't see it?
No.
All right, do you see my cursor?
Let me go out and the
Just make it bigger. Can you do Control plus plus? Here, I'll show you.
Alright.
Is it a Mac?
Yeah.
Okay, try Command plus.
Okay.
Horrific knows everything. I swear.
Sign me out.
Horrific is a bright cookie. You want to share your screen again?
I have to go sign in first because it's signing me.
I'll tell you what, I can do mine. I'll do mine.
Okay.
All right, so it doesn't matter which group it is. Special homework. Number 7. Okay, so here's this, and then I'm gonna go plus, 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 and make it big enough.
Oh, I didn't say oh my because
You
I
see what I mean? It's like
Mm.
minus, 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 plus, plus, plus. All right, great. So prove the following statement, use only the definitions, and we're gonna set it up. Okay, so it's number 4, right? Was it number
Yeah.
4?
Mhm.
So it says, if X is in Z, then X squared plus X minus 9 is odd. So this is very much like,
That's number 3. No.
oh,
It's number
oh, oh, this is the product of 3 consecutive integers is divisible
Yeah.
by 3.
Mhm.
Okay. The product of 3 consecutive integers. All right. I can stop sharing now. The product of 3 consecutive integers is divisible by 3. So if we write it as an if-then statement, because that was the hint, or, part A, write it as a conditional statement, right?
Mm.
So if N is in Z, then, and the product of 3 consecutive integers is N times N plus 1 times N plus 2 is divisible by 3.
Mhm.
Right? In other words, 3 divides that. Okay? All right, so here we go. Let's write the proof. Assume N is in Z. Now, what is D? We look to the conclusion to figure out what the divisor D is. What is D here?
3.
3. So the QR theorem, you got to invoke the QR theorem with D equal 3 says, and all right, so we apply the QR theorem to the object in the hypothesis. It will always be an integer, okay? So it says, hey, we can divide N by 3, and we're guaranteed we're going to either get that N equals 3 times Q, right? No remainder 0, or when we divide N by 3, we get a remainder of 1, so N is equal to 3Q plus 1. Or when we divide N by 3, N equals 3Q plus 2. And of course, Q is an integer. So that's how we set up our cases. Does that make sense?
Yeah.
I mean, the bottom line is we don't know what integer N is, but we know that whatever integer it is, we can always divide it by 3, and we're guaranteed we're going to get one of those 3 remainders. So we have 3 cases, right? This
Yeah.
is going to be case 1, this is going to be case 2, and this is going to be case 3. We wish to show 3 divides N times N plus 1 times N plus 2 in every case. We want this. We always want this, the wish in every single case to happen, okay? All right. So what's case 1 going to be? What should we suppose for case 1?
And it's 3Q.
Yep. where Q is in Z. All right, now what do we look at? What are we trying to say something about?
So we wish to show and
Yeah, shall we unpack our wish a little bit further?
yeah.
What does it mean to say that 3 divides n times n plus 1 times n plus 2? Let's unpack this divides wish. It'll make it easier so we can see what we need to look at. It means n times n plus 1 times n plus 2 is a multiple of 3, right? So it's 3 times, say, m, where m is some integer. Does that help?
Yeah.
You got to be able to unpack the definition of divides. Here's our definition of divides. Okay, so if we want to show that 3 divides this is our y, n times n plus 1 times n plus 2, that means that that y, which is n times n plus 1 times n plus 2, is equal to 3 times an integer. Call it k, call it m, doesn't matter. Point is, we're trying to prove it's a multiple of 3. You with me?
Yeah.
So now what? What should we look at? What should we start playing with?
N equal to 3Q. Oh.
We're
And
in the case where n is 3q, okay? We're in case 1. So you got that perfectly. We're going to look at this expression. That's why it's good to unpack the divides wish, because then you can see what it is you actually have to start substituting into. Does that help? This is the
so we're
expression.
gonna put like 3.
Yes, yes,
Okay.
yes. So here we go. So let's observe. All right, so we're going to look at n times n plus 1 times n plus 2. This case isn't so bad, all right? It's not so bad. All right, so n is 3q, okay? So we stick in 3q there for n, and then
And
3q, all
uh,
right, and then what goes here?
3 plus 2. 3.
Don't, don't forget,
Oh,
don't forget your
yeah.
q.
Yeah, 3Q plus 1. 2.
And it's not, you don't have to multiply all this out, Anticott. I said this, I showed you all this in class. We do not have to multiply this all out. Check it out. There's a 3 right there.
Yeah.
So just pull that 3 out, and then all this other stuff can stay exactly like it is, all these other factors. And we don't need to multiply all that out. We're going to be able to, just talk about why that's an integer. We're halfway there. We've got n times n plus 1 times n plus 2 looking like 3 times this. Now all we got to do is talk about why this is an integer. So what operations are being used to build this?
Multiplication and addition.
Good. So how should we write this part up? Help me.
So since Q is in Z,
Mm-hmm.
the sum of product of integer are integer.
Yes. And sums and products of integers are integers. Keep going.
Oh, M is equal to Q times 3, Q plus 1,
Good.
and 3Q plus 2.
Keep going. What should we say about it?
They are in Z.
Yes. Don't forget to say it's in Z. That's the whole point, right? So 3 divides n times n plus 1 times n plus 2 by definition of divides. And we finished case 1. Now let me show you how case 2 goes so I can show you that you don't have to multiply all that stuff out. There's an algebra trick. What would be our supposition for case 2?
So 3q plus 1, right?
What about 3q plus 1?
Divide, yeah, n equal to 3q plus 1. Yeah. Suppose.
Suppose, right, you gotta give a complete
Oh,
thought,
okay.
right? We need a complete thought, right? For Q is in Z. Same wish, I'm not gonna write the wish. We're gonna look at n times n plus 1 times n plus 2, and we're gonna show that it is divisible by 3, that it's a multiple of 3, right?
Yeah.
So let me show you the algebra trick here. N times n plus 1 times n plus 2. Now it's more complicated because n is a binomial. Uh, yeah, Ridvick, let me finish this and we'll get to that. And that's reasonable because that's due
Okay.
tomorrow. All right, so we have to use parentheses around 3q plus 1, right?
Mm-hmm.
When we put it in for n. So it's 3q plus 1, that's our n. Then it's 3q plus 1 plus 1, right? Because we put 3q plus 1 in for this n,
Okay.
and then but we got to add another 1, right? And then what do we write here?
So 3q plus 1,
Uh-huh,
2. Well, plus 1 plus 2.
plus 2. Now let's simplify this a little bit. We're not going to multiply it out though, because I'm going to show you
Okay.
this great trick where we don't have to multiply this all out, because check it out. There's a 3 that we can factor out of this factor. Do you see
Yeah.
that?
So we'll
See what I mean? So this is 3q plus 1 times 3q plus 2 times 3 times q plus 1. See what I mean?
yeah.
Now just pull that 3 out front, and then this m is going to be all of this multiplied together, but we don't have to multiply it out.
Okay.
All right, so, and then, argue m is an integer, right? You have to, do the same thing.
Okay. I will
Now,
finish it.
see it? Now, when n is 3q plus 2, it's this factor that's going to have a 3 that you can pull out of it, because this will turn out to be 3q plus 4, because it'll be 3q plus 2 plus 2. So you won't be able to factor the 3 out of here, but this will turn into 3q plus 2 plus 1 in case 3. This will be your 3q plus 3. This will look like that. And you'll just pull the 3 out of here, and you won't have to multiply these other ones together.
Okay.
All right, so I'll you finish. You do case 3.
Okay. Thank you.
You're welcome. All right, let me check and see who is in the room right now. Who is in the room? Okay, Eli's been here before you were, Ritvick, though. So Eli had a question that I need to answer first, since he was in the room first. So Eli, are you still there?
Yeah, I'm still here.
All right, what's your question?
I didn't really have any specific question. I just kind of came on just to do the problems that you're gonna be doing with the other students and just to practice it. And I'll
Oh,
just
okay.
ask questions if, because my thing is I just want to keep practicing it and just understand how you're doing it. And if I have any questions, I'll just put it in the chat.
I'm so glad you're here. All right, Ritvick, it's your turn.
Thank you. So I was currently doing like the special homework 8,
Okay,
and
good.
um like I have the contrapositive written down, so which goes like for all of x and double bar z, if x is not even, then 7x squared is not even. Although I would say if 7x is odd, which I don't want to use because I wanted to get into the habit of saying explicitly not q and not p.
Well, the thing about this is we actually want to use what we understand about integers. We know 7x squared is an integer, and we know that every integer is either even or odd. See what I mean? So to say it's not even actually is not as informative to us as saying, hey, that means it's odd. Do you understand? So I appreciate that you want to be, very precise. And if you want to say not even, that's fine, as long as you understand that because it's an integer, the quotient remainder theorem tells us if it's not even, then that means it's actually odd, because we're going to need, an equation. See what I mean? And the
True.
equation we get when we know an integer is not even is the equation that goes along with it being odd. Does that make sense?
Yes, I do want to write it out like specifically, like just to get into the habit of understanding the syntax of a contrapositive.
All right, so tell me what you want to write for the contrapositive.
Like I already said, if for all of x and z, if x is not even, then 7x squared is not even.
Fine. Full credit.
All right. So,
But I'm going to write also the formulation that a lot of students are going to write just for the purposes of the notes.
okay. But either way is okay. Like it's good.
Yeah,
As
either way
long as,
gets full credit.
yeah. Anyway, so I wrote down a proof by contrapositive. So assume x is in double bar z and x is odd because not even is odd, obviously.
Perfect. That's exactly what you want to do here.
So wish is 7x squared is odd.
So we wish to show 7x squared is odd.
Mm-hmm.
Okay.
And the definition of odd is x equals 2j plus 1. But for the purposes of this recording, you can use a different integer.
J's fine. What is
Good.
J? Oh, it's an integer. Good.
No, for the purposes of this recording, I want us to pick a different integer.
Then J?
Yeah, because I don't want to like them copy.
I don't think you need to worry about that. How about you let me worry about that part of the teaching, and let's just worry about making sure you understand it.
Okay.
So by definition of odd, x is equal to 2k plus 1,
Okay.
where k is in z.
Where k.
Right? Don't forget part 2 of the definition of odd. You got to, but you know that. You know there's 2 parts to the definition of odd.
And the wish actually is so I have for the wish x equals 7 times 2j plus 1 squared.
Well, that's not the wish that I get when I am trying to show 7x squared is odd. Because when I'm trying to show 7x squared has the form of an odd, I'm thinking, ooh, I need 7x squared to look like an odd number.
Yeah. Oh, okay.
See?
So 7x squared equals, okay, I had that. Anyway, so let's see. 7x squared equals and then for my observation, now I have again 7 times 2j plus 1 or 2k plus 1 or whatever. and squared.
Nice.
And I distributed 7 and 1 to 14j plus 7.
Nope, nope, can't do that. Please excuse my dear Aunt Sally.
Oh, dang.
Parentheses, right, exponent.
So,
So,
okay,
yeah.
so let's do, it's actually, whoops, it's 2j cubed plus 1 cubed because,
You mean squared?
no, you multiply. So we have 2k to the first power, so like there's no first power. So I just
Oh,
added.
oh, no, look, shall we work on, multiplying 2k plus 1 times 2k plus 1 over here? Let's do that.
Oh, okay. I thought we're talking about like the properties of exponents thing.
No, no, you don't, no, that's not, that doesn't, there's not a property when they're being added together. Like we have a property if it's x times y raised to a power p, that is equal to x to the p times y to the p, okay? But if you're adding or subtracting them, x plus y to the p, that is not equal to x to the p plus y to the p. There's a bunch of stuff in the middle. I mean, these are the terms on either end, but there's a whole bunch of terms from the middle.
Oh, okay.
So
All
what's
right.
2k times 2k? We'll do the firsts, the outers, the inners, and the
Yeah.
lasts.
So it's 4 k squared
Good,
plus 2 times plus 2k
good,
plus 2k
good.
plus 1, and so
Yeah,
that gives me 4j squared plus 4j plus 1.
nice. Good. That's what we do in here. Because this is not a rule. I'm so glad you came in and asked about that.
That was my first question.
But
I'm confused about this. I did two different way when I submit my homework. So
oh, okay.
Which one am I supposed to grade?
All right. Anyway,
In general, I beg you not to submit more than one solution.
yeah, but like the one I think was right, it was wrong. Anyway, the way you're doing, I submit this one too, but like the way I do the first one, I write it like I think this one is right on
Yeah.
it.
Yeah, Anticott,
And
then, okay, okay. All right, thanks for telling me. I'll keep my eyes out for
okay.
it.
times 4j.
Like I hate it when I grade like a whole problem and then I turn the page and it's a whole problem again. And I wasted 5, 6 minutes grading a whole problem. See, it's
Okay.
not fair to me.
I know.
Okay, but you told me, so I'll look out for it. So now we're going to distribute the 7. Does that make sense, Ripvic?
I actually did that. So it would be 28j squared
Uh-huh.
plus 28j plus 1.
Don't forget to multiply the 1 times
Oh, shoot,
7.
7. Okay.
Bang.
Which you can still do the plus 1, but you have to split 7 into 6 and 1.
Exactly. Exactly. So, you can save it by saying plus 6. Doesn't matter what order these are in, but eventually the plus one's going to hang off the end, right?
Okay. And then,
So it's nice to look at the wish and see what we're trying to get.
okay, so I would say factor out 28. Um, so we
Ooh,
have
ooh, ooh, ooh.
14j.
Wait a minute. Wait. Yeah. Factor out you meant to say 2, right?
Yeah, it's a 2. I was factoring out plus 14j plus 6. And this is all in parentheses plus 1.
Plus 3.
Oh, plus, whoops. Okay, so
And that's our
Got-
M.
Yeah, I got the M.
So that's great. And now we just need to finish it by doing the second part of the satisfying the second part of the definition of odd.
Okay.
So how do you like to write that up? You tell me what to write.
Hmm. So since M equals great. Oh, M is an integer.
Why though? What is M?
14K
Yeah.
squared plus
You're jumping the
14.
gun. Yeah, we're going to say that M is an integer at the end, but first we have to use this part of our definition. See, we have two pieces of proof money.
Yeah.
So we want to, you've got J, it doesn't matter. I mean, the point is, since K is an integer or J is an integer and Z is closed under what operations are we using?
Multiplication,
And we're also using
addition.
addition. Now you can say M equals that is an integer, right?
Right.
So just kind of want to first spend your money and then you get what you want, if that makes sense.
Okay.
So 7x squared equals 2m plus 1, where m is in Z, making 7x squared odd. By definition, odd.
Odd.
Nice. All right, so you got it.
Mm-hmm. All right.
All right, who's got the next question?
Oh, I have a question if no one else has a question.
Good. Shoot.
It's gonna be I can share my screen, but it's gonna be number 2 on special homework 7. Would you like me to share my screen?
Sure. That'll be fun. Homework number 7.
Yeah, special homework number 7.
Okay.
Let's see here.
Oh. Graphics. I got it. I pulled it up.
But yeah, okay. I don't know where my screen went because I had it up here.
That's okay. So this is special homework number 7, number 2. So we're going to suppose A mod 8 is 5 and B mod 8 is 7, right? Yeah. Find each and show appropriate work. It doesn't include using examples. We'll use our translation relationship. So what is the translation relationship between this fact and this fact and equations? We get some equations for A and B.
Is
A
it
yeah, you tell me what A mod 8 equals 5 gives us.
Yeah, is that gonna be A equals 8Q plus 5?
Yep. And Q is in Z. Great. All right, how about B mod 8 equals 7?
That's gonna be B equals 8Q plus 7.
But we can't use Q again. We
Oh, sorry,
already
yeah, not Q, yeah. 8J.
good. Or you can call them Q1 and Q2. Doesn't matter. All right, great. So we want to look at A plus B mod 8. So A plus B, well, is we got 8Q plus 5, that's A, plus B, 8J plus 7. You with me?
Yes, I am. That makes sense.
All right, so we're going to be trying to factor out all the 8s that we can, right? Because we're going to try to figure out what this is mod 8, right? So that means, all right, so we've got 8Q plus 8J plus 12. But 12 is too big to be a remainder mod 8, isn't it? Too big. Too large for a remainder when D is 8, right? Because the largest legal remainder is 7 when D is 8. Do you agree?
Yes.
So we have to apply the QR theorem to 12 and break it down and just see how many 8s fit into that, right? Well, that's 8 times 1 plus 4. See how that works?
Yeah, I see that.
And now that's, this turns out to be our A plus B mod 8 because that is a legal remainder. See, so now suddenly, we've got this equation and we can go back this way. And it's so A plus B mod 8 is equal to 4, right?
I
See what I
see.
mean? This relationship goes two ways. And so instead of just a single letter, this whole thing, it's like, the big Q,
Mm.
Does that make sense?
No, that makes sense. Thank you.
Sure. And same with number 2, 3AB mod 8. So we just, we say, okay, 3AB, what is it? 3 times A times B. And this takes a little bit more work, right? I mean, we gotta, what is it? 56 QJ plus what? No, 64. Oh, my bad. 8 times 8 is not 56. 8 times 7 is 56. This is 64. Plus 56Q plus 40J plus 35. But now we got to pull this 3 through here. I'm not going to actually multiply the 3 by these, except for this one. I'm going to say this is equal to 3 times 64 times Q times J. Because in a minute, I'm going to pull an 8 back out, right? 3 times 56 times Q. Or you can go ahead and multiply it out. Doesn't matter. You can write 120 or you can write 3 times 40 times J. But what we really need to get our eyeballs on is this remainder. And that's too big for D equals 8, right? It's way too big. So we just applied the QR theorem to 105. How many copies of 8 fit into 105? And what is the remainder? See what I mean?
Yeah, I got you.
So this is, 8 times something plus, and this will actually turn out to be the legitimate remainder. After you pulled out as many copies of 8 from 105 as you can using the QR theorem.
Okay, I see.
See it? So let's see. If we pull out 10 copies, that's 80, but then there's 25 left over. And 8 will fit into 25 3 times. So 10 plus 3 is 13. And I think that this turns out to be a 1. So this is 8 times 3 times 8J plus pull out an 8. This is 3 times 7Q. Pull out the 8 from the 40. This is 3 times 5. See what I mean? Like, we're pulling the 8 out plus 13 and then plus 1. And then we go back.
So
3.
basically, once I'm able to, so I should just go through and find something where I can pull, or go to the remainder and find a way I can pull out an 8 in this case out of the remainder. And once I do that, I could just make 8 multiply everything together.
Yeah. Yeah, well, 8 gets factored out and this is all added together. But I'm not sure what
Yeah.
you mean by multiply everything together. But the 3 has to be multiplied across for sure.
No, I get that, but like I probably didn't explain it right. I was basically trying to say how you put 8 and then in parentheses you put everything in there, and that's what I meant. I meant like,
Yeah, okay,
yeah.
yeah, right. This is the quotient. Like, when A is 105 and D is 8, this is the quotient and this is the remainder. A equals DQ plus R. Yeah.
Okay, awesome. All right, thank you.
You're welcome. And that's always the trick with these remainder games is you got to just break, whenever you get something that's not a legal remainder, you just break it down by dividing out as many copies of the divisor as you can so you get a legal remainder. Here we could only pull out one copy of 8, but here there's a bunch of them because of this, this was anyway big, right? We could pull out 4 copies of 8 from here and the remainder would be 3. But when we multiply that by 3, then suddenly the remainder is 105. I mean, the remainder turns from 3 to 1. Yeah. Good. Folks, it is 9:04. Does anybody have a burning question? I'll take, a burning question. But I've got about 6 hours of grading ahead of me, and I'm going to try to split it between tonight and in the morning before I teach. So I got tons to do, and still I got to post all this stuff up. So
I don't have any other questions. Good night for now.
good night, Ripvic. Thanks for coming.
Good night. Thank you.
You're very welcome. Thanks for playing.
Mhm.
All right, thank you, Professor.
You're welcome, Eli. I'm so glad you came into office hours. See you next time.
Yeah, I'll see you when the test on Monday.
Well, we've got an office hour on Sunday.
Yeah, I'll see you then. Yeah, because I put on.
Fantastic.
Cool.
All right.
Okay, thank you.
Take care. Bye-bye.